Hi, this is pre-calculus, and we're going to be dealing with investing and mortgages. And we want to look at some, there's three formulas that we're going to use. There's many more formulas overall, but these are the three basic formulas that we want to look at. The first one is the savings account formula. And then we're going to get into the mortgage formula, and then we're going to get into the annuity formulas. So with this one, here's our formula. And what this talks about then is the amount of money that we have at a certain amount of time. Sometimes you'll see A of t is equal to P 1 plus W to the NT. Now, sometimes you don't see this W here. What you'll see instead is N divided by T. Well, I'm sorry, R divided by N. And so this W here is equal to my R divided by N. And so instead, I'm going to use W, which we call our working interest rate. A of t is going to be our amount at a certain time, and then P, capital P, is our principal. That's the original that we put into the bank. And then N is going to be the number of compoundings per year. We're going to use N equal to 12 for most of our examples, which means that it is compounded monthly. If it was quarterly, it'd be N equal to 4, and so on. Okay, and then T is your time in years. So let's look at this example. I'm going to deposit $8,000, and I want to put it in at 6% for 10 years. Now, at this present time, you can't get 6% hardly anywhere, but I'm going to use that because it's more meaningful in our numbers when we look at it. And so what I want to figure out is how much money would I have after 10 years. So I would say my amount after 10 years, I'm just using this formula here, and it's not A times 10, it's A of 10. This is your amount after 10 years, is equal to the principal, which is 8,000, and then I'm going to go times 1 plus my working interest rate. I didn't calculate that yet, but the working interest rate would be my 6%, and I don't use the percent value. I'm going to use the 0.06 by moving the decimal place over to here, and I'm going to divide by 12. That would give me a 0.005 working interest rate. What does this mean? Well, the bank isn't going to pay me 6% every month. There's no way that they're going to do that. But what they will do is they'll take this annual rate and they'll split it up into 12 equal parts, and then they will pay me this rate right here per month. And so that's what we're doing. So this would be 0.005. Now, if I just look at this formula as it is, this would be 1 month. And so ignore this 10 right now. And so what this does is that if I just did 8,000 times the 0.005, that would give me the additional money that the bank is paying me. But I need my original balance. So if I call up the bank and they just tell me what the interest that I earned, and they said that's all you got in the bank, I'd be pretty mad. I still have my original principal in the bank. So that's where the 8 times 1 comes, or this value of 1 comes from. And my money is growing, so I need a factor that's greater than 1. And now I can raise this. That would be after one month, and I can continue to do this monthly, every month for 10 years. So I just use that as an exponent to simplify things. Then I get 8,000 times 1.005 raised to the 120th. And if I do this, I get approximately, here's punching the calculator, I get $14,555.17. Not bad for just letting your money sit there, as long as inflation rate is less than 6%. You're not losing on your money. If the inflation rate is greater than 6%, then you lose on your money. And so this is the value that we'd have here, and that would be after 10 years. Hopefully you can use that, or you should be familiar with that formula. The next one is the mortgage formula. Now, most of you are not familiar with this because you've never taken out a mortgage, but most of your parents have, or many of your parents have. But a mortgage is a home loan. And so what we need to do, though, is to figure out and calculate the home loan appropriately. We need to figure out the payment. Now, this is a fancy formula. Little p stands for the monthly payment that we need in order to calculate these things out. Big P is your principal. W, again, is your working interest rate. And then N times T, that's the same as above. And so when we put this in together, let's do this example. What if I borrow $8,000 for 5 years at 6% interest? I need to find the payment. So if I want to find the payment, what I have to do is just really plug and chug. So P is equal to, I got my 8,000. My working interest rate again is 0.005. And I don't have a 1 in this one out in front. Then I do have a 1 inside. 0.005 raised to the NT. So I'm doing this monthly again. And that would be 12 times 5. And we do this all divided by whatever it says there, 0.005 raised to the 12 times 5 again. And that is multiplication there, and then this would be minus 1. Now, if you ever do this in your calculator, what you have to make sure that you do is you do put big parentheses around this because this is all in your denominator. Go ahead and try to figure out what that payment would be. Remember, this is little p using your calculator. So I'll pause here, you find it. So I got 154.66 so that would be your monthly payment that you'd end up with. If you're having trouble finding that number, remember that you do have to group this one in the denominator, and then this exponent is 60. 12 times 5 is 60. Maybe you're making an error with that, with parentheses or something. But go and double check that. Okay, now the other formula that we have is something that's called an annuity. And what an annuity is, as compared to our very first example is that we just put in $8,000 and we let it sit. But what happens to most people is that they put in a little bit every month. It could be $100, $1,000, depends who you are. It could be $10. Whatever you can save, you can save. That's great. So let me write up an example here, and we'll look at this annuity. Okay, here's my example then. If I invest $155 per month, that means I'm just putting in $155 every single month at 6% for 5 years. Well, that's going to accumulate to a nice little sum. How much would you guess how much that would be? Well, I don't know where you're at with your guesses, but let's calculate this and figure this out. So my amount after time t, sometimes I write a of t, sometimes I don't, but your amount after time t is going to be your 155, which is your payment. This is lower p. And then I put in brackets with the parentheses 1 plus 0.005 raised to the 12 times 5. Once again, I'm compounding 12 times a year and then times 5 years. And then I got minus 1. That's all in the numerator. Group that together, and then I divide by 0.005. And if I calculate this, which I did go ahead and do, what'd you guess? Well, we got $10,000. It's the second one that we're looking at. We have $10,000, and it's $10,814.35, which is a tidy little sum for 5 years. So any amount that you can save per month will make a little bit of difference. Here I did the 154 just to see what the difference would be. Just $1 more for those 5 years every month would equate into about $70. $60 for $70, I'll take that. I'll take that trade. And so this is approximately equal to $10,814.35. Thank you very much. Not bad. Okay. Now we're all different places with whatever amount of money that we can save, etc. But the main thing is that if you can start saving when you're young, the interest and time and the compounding will help you out quite a bit. And that's your key to saving for a lifetime. Okay, now if we go to the examples, this is something that you'll see if you read this example first. Pause if you have to. But you'll see APR and APY. The banks a lot of times will advertise the APY because it's a little bit higher than the APR. And what happens is this: what is your effective yield? How much do you actually get after the course of 1 year if they are compounding monthly? So let's use this example. So if I take $8,000 and I place it into the bank at 6%, so remember that that's monthly interest rate is 0.005, and I want to, that's my working interest rate already. I don't have to divide it by anything. And then I raise it to 12 months. If I calculate that out, I'm going to get a value 8493 and some change. And I got the value here, so it's 42 cents. Okay. Now, what's the difference? Well, we want to know, is this actually 6% more than what we started off with? Well, what we can do is to find the APY. You can do it different ways, but one way is to just take what you got after 1 year and divide by what you originally put in. And if you calculate that, you get a value of 1.0616775. This is showing how much more than one full 8,000 that you originally started off would be. So this value right here would be your APY. That's your yield. So you actually, since the compounding works, you're actually getting a rate that's a little bit higher than the APR, which is the 6%. Okay, and so then we can do this again with 10 years. We already did this on the previous side. And here's a question for you. When will my money double? Well, we can use some of the information that we had before. So we have 8,000, 1 plus 0.005 raised to the x is equal to, I need a double, I'm going to get 16,000. And when I do this and solve this out, why don't you go ahead and pause this and do that, see what time that this will double. So if I set this equal to 2, because I just divided both sides by 8,000, I can take the log of both sides. Doesn't matter if I use base 10 or base e, and then I can bring the x out in front, and then I can just solve for x by dividing both sides by the ln of 1.005. So this is ln2 divided by ln 1.005, which is approximately 138 and some change. Now, what happens with this, this would be my x value. Well, what does that mean? It's going to be 138 years? No, remember that x is n times t. If I'm going and doing this to the monthly, compounding monthly, then what I need to do is take this 138 and change and divide it by 12, and that would give me a little bit over 11 years. I got it on my calculator here. 11.58 years. So not bad. If you look at an interest rate of about 7.5%, that would usually take 10 years to double. And if you had an interest rate of 10, then it would take about 7 years to double. So the higher the interest rate, the quicker that this thing will work out. Now what we want to do is try to write a spreadsheet eventually for this same information. And what we want to do is set up repetitive calculations that exhibit our exponential functions. So if I take $8,000 and I put it in, I'm going to have $8,000. Now with this balance, after 1 month, I still have that $8,000, but the bank is going to go, hey, thanks for having your money with us. We want to pay you some interest on this money. So what will happen is that you'll get a value here of 8,000, and they're going to multiply by 0.005. Okay? That would tell you what your interest is. So what happens is that I can take this 8,000 multiplied by 0.005. There's $40. That's how much the bank is going to pay me for having my $8,000 in the bank. Now in this case, I'm just looking for what the interest is, so I'm just multiplying by 0.005. If I just wanted my balance, I would multiply by 1.005, which would be 8,040. Now we're not going to make any more money because this is just a regular savings account. Now I'm going to take these two values and I'm going to add them together. So I get 8,040. Then I'm going to take this one and I'm going to put it down here, 8,040. And then I need to find out my interest. So it's 8,040 times 0.005, which is equal to whatever value that is, which is $40.20. No, I don't want to round that. I want to take every penny that the bank will try to give me. So I'll take this 40.20 and add it to my 80.40, and so I'm going to get, I'm having problems here. I tried to take too much from the bank. This is 80.80 and 20 cents. Now you can just continue on with this down the line, and then you can figure out how much you have at a certain amount of time. Now, if I want you to do a few more just so you get the hang of this, but really if I ask you to fill this all out by hand, that's not fun. And so what we want to do is we want to build the spreadsheet out of this eventually. Okay? Now you might have to search for some of these finance terms down at the bottom of the page and just get a description of what's going on there. I think that would be great. Moving on to the next one, the mortgage, you need to calculate the payment. Okay, 6%. Working interest rate, we already found out. Why don't you pause and read this first? Okay, but it's pretty much the thing that we started off with. And this is just for 1 year. So we calculate our payment for that 1 year. So P is equal to my principal and then my working interest rate, 1 plus my working interest rate, and I'm going to raise this just to the 12 because I did it for 1 year. In my previous example, I did it for longer, but this one I just want to do for 1 year. And then I'm going to take 1.005 from here, raise it to the 12, and subtract 1. Remember, if I put this in my calculator, I got to cover that up. So go ahead and figure out what that's going to be. I got approximately $688.53. So what I want to do with this is I want to do similar to what we just did. I want to make this payment $688.53. Now this is a mortgage. I have to pay off this amount that I owe. Now of this payment, I'm going to pay a certain amount to the interest. I owe this 0.005 on this $8,000. So what I'm going to have to do is I'm going to take my $8,000 and I owe 0.005 on it because I'm holding that money right now, which once again is my $40. My principal paid then would be $648.53. Now, since this is such a short-term loan, this amount of interest is very small relative to my payment. It's not a big deal. But if your loan is 30 years, you should see what happens. A lot of times this interest paid would be more than your principal paid at the beginning of your loan, while at the end of your loan, then the principal paid becomes more and more. So in other words, you're paying a lot of interest at the beginning of your loan to service this thing. Now, what's my new balance? Well, it's going to be 8,000 minus this 648.53. So I took my 8,000 and I subtracted this principal. The principal is the amount that I owe that I'm paying off this payment of 688. So I can take the 8,000 minus this and I get 7,351.47. This $40, as far as I'm concerned, goes poof into the air and really into the banker's pocket. So now I have a new payment, 7,351.47. Your payment made is going to be the same. And then your interest paid is going to be now 7,351.47 times 0.005. And you can figure out what that is. And then the principal is just going to be this amount minus your interest paid. That would be your principal, and then I can take the principal away from that and get this value here. So continue that on and then see what happens with this loan. Okay? Then my last example, and here's some more terms, and I want you to search some of those and figure out what those terms are and answer some of these questions. And then the annuity is a little bit different. So let's set this up, and you can search a little bit for this. And she makes the same 6%. What I need to do, though, is figure out what my deposit's going to be. And to get to see the fairness of all this, I'm going to use the same mortgage payment that we had before and see what happens after the course of 1 year. So my deposit's going to be $688.53. And then that's just my balance yet. Excuse me. And so if I take this, I'm going to take this over here. And now they're going to pay me interest on that. And so the Annuity is an investment. And so what I'm doing is I'm taking this 688.53. They're going to pay me the 0.005 again. And the value that I get from that the value that I get from that is going to be $3.44. And so all in, what I'm going to do is then I'm going to make another deposit, 688.53 every month, coming out of my paycheck straight away. That's the best way to do it. Is that I'm starting to feel like I'm sounding like Susie Orman. So what happens is that I had a previous balance of 688.53. I paid some I was paid some interest, $3.44, and then I made another deposit. So now my new balance is going to be all three of those numbers together. So I end up with 1380.50. So I bring this over here, and then I'm going to figure out my new interest, figure out deposit made, and then the new balance again by adding those three values. And keep on doing this for 1 year and see what happens with all those values, and see if you can answer most of these questions and get definitions for all of these values. In class, then, what we'll do is we'll talk about some of these questions that we didn't get answered in the video, and then we'll start on the spreadsheets and how to build that. Sorry, I'm bopping around here a little bit. But thanks for paying attention, and fill in that sheet as much as possible within reason until it will make you sick, and then maybe you use a spreadsheet. Thank you very much.